Hello, Maurieo! In this video I'm going to calculate curves with deflection angles and chord lengths so that we can set them out from the tangent point. So really looking forward to that. So let's see if we can get our curve up. And here's our curve. This is the one that we're going to deal with. So the question that we're being asked is calculate the deflection angle and chords from BC to all the even chainage stations along the circular curve. So that means we could sort of set them out from BC in the traditional old school style, but nonetheless it's helpful to give us a good understanding of how these circles work. So we've been given the coordinates of BC and CP. We've got some bearings here, 54 1740 and 166 1740 here. So let's just start up. Run to the missing line from the coordinates, which I've shown you in previous video, and we do that. Here's our coordinates here, 7140 415 it is, just 7140 and 3456 286. So yeah, we get the bearing 144 1740 for 67.451. So just note that is at right angles there. The radius is at right angles to the tangent, and similarly here. So next thing to do is to calculate the centre angle. Obviously if we calculate it up here, we've got to go past the 360. So let's do it out the back door. So 256 1740 going that way, 144 1740 that way. Take them away, 112 degrees. Want to calculate the arc length. So as we know, full circles 2 pi r. We only want 112 out of the 360 degrees on our arc, so 112 over 360 times 2 pi times 67.451, which is the radius, which we calculated from our coordinates there, gives us 131.851. So next step is calculate chainage 240. Now the arc length, as we say here, BC has the chainage of 232.65. Take that away from 240 gives us 7.35. So we want to go 7.35 along the arc. Along the arc, not the chord, remember, along the arc. So we need to find out, or what we're going to do is work out what the angle at the centre would be for that length of arc. So clearly 7.35 would be the angle, theta, over 360 times 2 pi r, 67.451 being r, the radius. And then we manipulate that equation and we get theta equals 7.35 times 360 degrees divided by 2 pi times 67.451, and that gives us 6 degrees 14 minutes and 36 seconds, which is this angle here, subtending the arc of 7.35, and that's the chord in there. So the arc 7.35 and the chord is what we're going to actually work out as we move along from this one here. So 6 degrees 14 minutes 36 seconds. So just moving along with that, here we are, 6 degrees. Now we're going to start to look at deflection angles and what have you. So let's first of all let you know what the deflection angle is, and it's the angle here between the chord and the tangent to the curve and the chord. It's that angle there. You may see other angles labelled as deflection angles, but for the purposes of this exercise, that is what we're talking about as the deflection angle. So it's how much we're deflecting the curve. Although there's some that call this angle around here the deflection angle, which, that's another story for another day. So there's our deflection angle there. So just noting, from the old, I'm so pleased to be able to remember my geometry from my fifth form days in school back in the 1960s and 70s. So one of the things I remember or memorised for my exams, the angle between a chord and a tangent is equal to half the angle at the centre. So this angle here, the deflection angle, is actually half this angle at the centre. Hello, this angle is 6 degrees 14:36. I thought it was 36. Okay, so well, I'm just going to pause there for a minute and change that to. Alright, so it's 36 now. Alright, so that's much better. So yeah, we have that to give the deflection angle, which is going to be 3 degrees 0718. 3 degrees 0718 being our deflection angle up here. Let's just write that in here while we're here. So that's 3 degrees 07 minutes. Oh, now it decides to give up the ghost. 18 seconds. Okay, so there's our deflection angle, 3 degrees 0718. Now, what we want to do is we want to work out the chord. Now, we've got our deflection angle here as 3 degrees 0718. Now, if with using symmetry, if we cut the chord in half and make that there, that's going to give us half the chord, and this angle in here is going to be 3 degrees 0718. So if we take the sine of 3 degrees 0718 and we multiply that by the hypotenuse, because sine equals opposite over the hypotenuse being the radius in this case, we get 2, so 2, and we want to take 2 of them because there's 1, 2, so we're just working in that triangle, 1, 2. So 2 times sine 3 degrees 0718 times 67,451, the radius, gives us 7.346. So there's the deflection angle, there's the chord. So now we move on to the next one, which is obviously it's going to be another 20 meters down the arc. So it's going to be whereas the first one was 7.35, this one's going to be 27.35. So we just pretty much go through the same process. The center angle is 27.35 times 360 divided by 2 pi times the radius 67.451, which gives us 23 degrees 13 minutes 56. 23 degrees 13 minutes 56. And there we are. There's another one that we need changing, so I'm just going to. Okay, so there we are. We've changed that one to 23 degrees 1356. We're going to divide that by 2 to give us the deflection angle, 11 degrees 3658. We then take the deflection angle, we take the sine of that, multiply it by 2 and by the radius, and that gives us 27.163. So there we are. We have the deflection angle and chord for the chainage of 260, my apologies, 260. So let's just have a look at another one here. So and you can see that if you move on to do the next one, you just add 20, so it'll be 47.35. Work it out for that, do the same one. Just one step here, the chainage at EC, because that's where we're sort of going to end this story today, and then we'll carry on along the straight or along the tangent there. So 232.65 here, plus the arc length, which we worked out on the previous slide, 131.851, gives us 364.501. So that would be the chainage at EC. And the deflection angle, of course, because we've got 112 divided by 2 would be 56. And the chord length, still the same as before, 2 sine 56, alright, times 67.451, the radius, is 111.839. So all that remains now is to calculate out the, just by adding 20 each time, calculating out the even chainages, 260, 280, 300, 320, and 340, and 360, and then we'll just go to EC. So I'm not going to do that for you, but what I am going to do is transition over now to a table that I have compiled showing the various chainages all the way through with the deflection angles calculated as I suggested previously, and with all the chord lengths, and finalizing with the last one, EC 111.839. And so we've calculated the other points and we've tabulated them, and there we are. We've calculated that curve with deflection angles and chords, as we said. Now, if you need copies of the notes or this video, need copy of the notes for this video, just email me, maurieo@maurieo.com. That's all lowercase letters. Although my YouTube channel is Maurieo with O as a 0, my actual website is Maurieo as a lowercase O in the alphabet. Need a problem solved? Yeah, I do requests. I can do anything. You just have to ask me. Cheers, Maurieo.